पूछ रही है वो भी पूछ लेना। अच्छा ये वाला पेपर हम शायद कर रहे थे। नूर एक सेकंड मैं ज्विटराइंस बता देता हूँ जस्ट वेरी क्विकली ज्विटराइंस ठीक है। उसके क्वेश्चंस वगैरह भी कि किस तरह के आते हैं। पता नहीं क्यों स्टार्ट हो गया। अच्छा ज्विटराइंस
सर मैथ स्पेक्ट्रोस्कोपी के अलग से 3-4 क्वेश्चंस करा दें।
बस ठीक है। वो पूरी मैंने एक प्लेलिस्ट बनाई हुई है उसकी वजह से। प्लेलिस्ट ही मैंने सॉरी एक वीडियो बनाई हुई है जिसका सिर्फ उसके लेटेस्ट क्वेश्चन है। वो मैं सेंड भी कर दूंगा। जी कहाँ से। अच्छा एनीवेज दिस वन ज्विटराइंस सिंपली है कि व्हाट हैपेंस इन ज्विटराइंस इज के you've got an amino acid carboxylic acid होता है उसका एक साइड पे there's NH2 that's a basic group ठीक है। there's an H and then there's something on the fourth side ठीक है some different carbon chain ठीक है that's on the fourth side. अच्छा zwitterines are that the acid part would lose H plus 1 ions ठीक है it's an acid ठीक है that's why तो यहाँ का जो acid का जो H है ना that's lost and it will become -1 ठीक है and the H plus 1 is lost right and the base can accept an H plus 1 ion ठीक है so the base over here it can accept because it's got a lone pair तो वो बाहर से ना somewhere from outside it can the lone pair can attract an H plus 1 ion and form a dative bond with it and it can accept an H plus 1 ion ठीक है so that's a basic part. So a zwitterine is formed zwitterine की definition they're going to ask you about the definition of a zwitterine which is that it's an ion which has regions of both positive and negative charges but no overall charge. So this is what a zwitterine looks like. It's got regions of both positive and negative charges but no overall charge. So amino acids they tend to form zwitterine कि उनका जो amine है ना that gains an H plus 1 and the acid loses an H plus 1 ion ठीक है। लेकिन हर दफा ये नहीं होता। A lot of times what happens is कि it depends on the conditions ठीक है। So you've got a basic side and you've got an acidic side. Now the acid side will only be activated under a basic medium. अगर medium basic होगा ना if you've got a lot of OH ions then those OH ions, negative ions, will attract H plus 1 ions and the H plus 1 will be lost and it will become a positive ion. Okay, so, but that only happens if the conditions are basic. Okay, so basic conditions may the base will be inactive, but the acid will be able to lose the H plus 1, so it will form a positive ion. Vice versa, अगर आपका जो medium है ना, that is acidic. Acidic environment में क्या होगा कि there's going to be a lot of H plus ions. So the basic part will get activated. The N lone pair will accept H plus ions. So base जो होती है ना वो active कब होती है when there's an acidic medium and the acid will be active when there's a basic medium. So acidic medium के अंदर the base would actually look like this. It's going to the lone pairs will form a dative bond to H plus 1, so it will become a positive ion. ठीक है? So somewhere under neutral conditions में क्या होता है कि you've got an equal amount of H plus 1 and OH ions. that both things happen. So the acid would lose H+1 and the base will gain H+1 at the same time, and that's when it's going to form a zwitterine. So somewhere around the neutral pH, you'll have a zwitterine formation. ठीक है, acidic में कुछ और होगा, basic में कुछ और होगा, but somewhere in between it's going to form a zwitterine. Now the thing is that the strength of the acid and base are different. So sometimes if you have a very weak acid does not ionize that much. So if you have a very weak carboxylic acid, it doesn't like to lose H+1 that much. So क्या होगा, you would have to make the medium very basic. ताकि उसका H+1 जो है ना, that can be lost and absorbed by the OH ions. So sometimes if you want to make a zwitterine, you would have to make the medium slightly more acidic because slightly more basic because your acid part is a weak acid. Or sometimes the opposite happens. Sometimes the base is very weak. So if base weaker, so you would have to sort of add more H+ions. So those H+ions can get attracted to the lone pairs. So the point is that ये जो zwitterine होता है ना, that's somewhere in between, but formed in between. Like it's not exactly pH 7. Sometimes it's slightly an acidic medium. Sometimes you need a slightly basic medium for a zwitterine to form. Like an extremely basic medium, may the carboxylic acid would lose H+1. Extremely acidic medium, may the N will gain H+1. And somewhere in between, it's going to form a zwitterine. Zwitterine, and that point is known as an isoelectric point. So it's the pH at which zwitterines get formed. ठीक है, ये clear है? और बाकी ये, अच्छा बाकी ये के जो मैं उसका बता देता हूँ. Remember atomization और bond energy में फर्क है. For example, बल्कि इसको पहले complete कर लूँ. Isoelectric point, ठीक है? And your questions will be about was zwitterine questions other than electrophoresis. That way you have a positive plate and you've got a negative plate. So a lot of questions about amino acids related to zwitterines will be about that. So if the amino acid is in the form of a zwitterine, it has no overall charge. So electrophoresis, it's going to stay wherever it is. It's not going to move right or left. Or vice versa, agar wo, let's say the acid is not able to lose its H+1, then it's going to be a positive ion. A positive ion will get attracted to the negative side. Or vice versa, if the base is not able to gain H+1, but the acid is able to lose its H+1, it will form a negative ion and it will get attracted to the positive side. So your amino acid will move, or दो factors होते हैं which depend on which the movement depends. One is charge, कि किस direction में move करेगा. The other one is the mass of the amino acid. चलो ठीक है. Zoe, your question is कि atomization and bond energy, right? So Cl2 gas breaking up into two Cl atoms. Okay, so that's bond energy of Cl. That's it. So this is the bond energy of the Cl-Cl bond because you've broken just one bond. Lekin when you talk about it in terms of enthalpy change of atomization, the enthalpy change of atomization of Cl is basically one atom of Cl getting formed. Here you're forming two Cl atoms. So this is basically equivalent to 2 times the enthalpy of atomization of Cl because you're forming two Cl atoms. So technically bond energy of Cl-Cl is basically equal to 2 times the enthalpy change of atomization of Cl. You end up with two gaseous atoms of Cl. Okay, so is this clear?
Could you repeat that again, please?
Because put equation, what is this equation representing? It's you're breaking just one bond, right?
Yes.
Enthalpy of atomization, here definition. Okay, 1 mole of gaseous atom gets formed from its constituent elements. You're forming 2 moles of gaseous atoms. So ये जो equation की enthalpy change है, that's equal to 2 times the enthalpy of atomization of Cl. Is that clear? Because you're forming two Cl atoms.
Right. Okay.
So basically, the bond energy of the Cl-Cl bond is equal to 2 times the enthalpy of atomization of Cl. तो normally क्या होता है कि bond energy usually the bond energy is basically 2 times, normally ये होता है, bond energy is basically equal to 2 times the enthalpy of atomization of the particular element. O2 के साथ भी यही होगा, 2 atoms बनेंगे. ठीक है?
Could you try it with an example like formation of Na2O from oxygen and sodium?
So Na plus
Like-
O2, that's a 30, 1 second. So
with both bond energies and atomization, like show the difference.
so formation is Na solid plus Na2O, right?
Na2O, yeah.
Na2O solid, right? So that's half O2, that's 2 Na and half O2, right?
Yes.
So you're going to atomize it first. So 2 sodiums gaseous atom. So that's enthalpy of atomization of Na. And you're going to form 1 oxygen gaseous atom, right? So that's equivalent to enthalpy of atomization of oxygen, right?
Like just one. Yeah.
You're forming 1 gaseous atom. So this is just
Yeah.
1 enthalpy of atomization. Like in terms of bond energy, how many bonds did you break? Like O double bond O, that's you're breaking 1 bond, right?
Yeah.
But you've got half a molecule, so that means you're breaking half bonds of O double bond O, right?
Right. Okay.
So in this case, when the enthalpy of atomization is basically half the bond energy of oxygen bond, right?
Yeah. Yes.
So इस पर confusion होती है, ठीक है? Just remember this. So ठीक है, I'm कोई और question तो नहीं है किसी का?
Sir, could you show the reactions between like PCl5 and benzoic acid, like when it's turning into like an acyl chloride?
PCl5, right?
Yeah,
So
or any of
POCl,
the
POCl3 and HCl is formed. So it's given over here. POCl लिख देता हूँ एक second. Let me just try benzoic. Not benzoic acid, just any carboxylic acid, right?
Yeah. Yeah.
So it's going to form RCOCl. Plus POCl3. ठीक है, HCl का मैं देख लूँ. Is this equation balanced? It's I'm left with 5 Cls. I've got 5 Cls on that side as well. हाँ ठीक है, probably HCl होगा इसमें. But let me check
Okay.
the in notes के अंदर भी होगा, एक सेकेंड. यहाँ पे गई. One second. This one, yeah. HCl plus POCl3, right?
Yeah.
PCl3 के साथ it forms H3PO3. I mean, one way you can remember this is that P is plus 3 over here, P is plus 3 in H3PO3 as well. P is plus 5. It's also plus 5 in POCl3 as well. तो इतनी reaction है, ठीक है?
Right.
इतने ज्यादा नहीं आते, आएगा तो एक ही मार्क का आएगा ज्यादा, ठीक है? So I'm going to continue with the past paper, ठीक है, which we were doing. तो ये वाला कर रहे हैं. अच्छा, use KW values to calculate H plus 1 in pure water under standard conditions to your working, ठीक है? So what is KW? KW is H plus 1 concentration times OHN concentration. Both ions will be produced in equal quantity. So x mole per dm cube, x mole per dm cube. What is the value of KW? That's 1 times 10 power minus 14. So that's equal to x squared. So अगर वो, so x would be 1 into 10 power minus 7. That's it. तो फिर वो कह रहे हैं कि the pH of pure water pH of pure water at 50 centigrade is 6.64. Now, if the pH is 6.64, remember H plus 1 concentration will be 10 to the power minus 6.64. ठीक है, anti-log, inverse log. pH is 6.64. H plus 1 would be 10 to the power minus 6.64. OH भी यही होंगे because pure water will have both ions in equal quantity. So if it ionizes, it's going to produce them in equal amounts. So your new value of Kw is going to be H plus 1 concentration times OH ion concentrations, and you would just multiply that. So it's 10 to the power minus 6.64 multiplied by 10 to the power minus 6.64. ये कोई बता दे कि क्या आ रहा है. ये बल्कि चलो आगे कर ही लोगे.
5.24 into 10 power minus
Speed में
14.
he will not be working out. ठीक है. अच्छा, अगला वाला कि there's 3 compounds. Hold on a second. नहीं, queries आप भेज दो. I'll answer queries as well. Well, now I'll be doing this past paper. So use data to calculate delta S values for this. Delta S is what? Products minus reactants, right? So delta S is going to be the entropy of the products minus the entropy of the reactants. बल्कि साथ ही marking scheme ताकि हम जल्दी questions go through कर लें. Working सारी वहीं से देख सकते हैं. मतलब sorry, values. Nishwa, KW का last part. अच्छा, last part में फिर से repeat कर देता हूँ कि जो होता है that ionizes, right? So water ionizes and produces what? H plus 1 and OH ions. अगर pure water होगा, it's going to both ions would be produced in equal quantity, right? तो होता ये कि if they've given you the pH say you can directly figure out H plus 1 concentration. So pH is given of pure water at 50 centigrade. 50 centigrade पे क्या होता है? There's more ionization of water. So the concentration of H plus 1 as well as OH ion changes, but it's going to remain equal. So pH से ना you're able to figure out the concentration of H plus 1 ions. So OH ions की concentration would be exactly the same. ठीक है? So the pH was given, right? So you were able to figure out Kw. Kw is the product of the two things, and that's going to give you product निकाल लो उसका. ठीक है? Kw की value जो होती है, that's 1 times 10 to the power minus 14, but only it's 1 times 10 to the power minus 14 if वो 25 degree centigrade के ऊपर standard conditions में. उसका वो निकाल लेते हैं कि we found Kw area. ठीक है, this comes out to be 189. Product minus reactants, ठीक है, that's 189. Agla part, use the value of delta H in your answer to calculate the temperature at which this reaction proceeds. Where the reaction becomes when what happens? K delta becomes less than 0. Delta be less than 0. But the हेलो, हाँ, आवाज आ रही है? मैं डिस्कनेक्ट हो गया फॉर सम रीजन. आवाज आ रही है? As I said quickly. for a feasible reaction. So delta H जो है, that's given, that's 118. Temperature, उससे क्या is find out the temperature, right? So you have to figure that out. So T is unknown. Delta S is already calculated, but remember one thing, that delta H is in kilojoules, delta S is in joules. So when you use delta S, turn it into kilojoules. 189 divided by 1000, delta less than 0, okay? And the rest of the formula would be exactly the same. You'll just solve it and you'll get a value of T, which is what? Which is, यहाँ पे उसे calculate किया हुआ है, ठीक है? So his T comes out to be 624 Kelvins. Okay, so find that. Solid lead 2 oxide can be made by heating lead metal in air. Predict the sign of the standard entropy change of this reaction. So lead metal being heated in air. So lead 2 oxide. So that's half. This is a solid, this is gas, and this is a solid as well. So gas ke moles kam honge, that means delta S is going to be negative. Moles of gas explanation kya hogi? Whenever predict the sign, explain karne ko keh raha hai, so that means you have to explain it. So moles of gas, they decrease. So next part, describe fully what you would see when magnesium and strontium are heated separately in oxygen. Iska jo hai wo kya hai? White flame hota hai, और strontium का जो होता है, that's strontium का क्या होता है? White flame, strontium का red flame है, sorry. Strontium is red flame, and अच्छा एक mark सिर्फ उसने flame का दिया हुआ है. So the flame carried just 1 mark. The दूसरा mark था, a solid oxide would be produced, and that's going to be white in color. Write an equation for each of the following processes, including state. Calcium is burned in air, so equation calcium plus oxygen, calcium oxide. Calcium carbonate is heated strongly, that's calcium oxide plus carbon dioxide. ठीक है, ये सारा. Calcium hydroxide is formed when water is added to calcium oxide. Calcium hydroxide and calcium carbonate are both used in agriculture. Describe the main benefit of adding calcium hydroxide or carbonate to reduce acidity in soil. Explain why group 2 hydroxides become more soluble down the group. Ye question bahut aata hai, theek hai? It's a 3-mark question. Why do the solubility increase down the group for hydroxides? So you've got MgOH2. It will dissolve, it will form Mg2 plus aqueous plus 2OH minus 1 aqueous. So this is your enthalpy change of solution. When you want to dissolve something, so how do you dissolve? You first turn it into gaseous ions. So Mg2 plus gas plus 2OH minus 1 gas, and then you hydrate them. So it's breaking the lattice, which is endothermic, and so that's lattice energy inverse ulta. And this part is exothermic, that's enthalpy change of hydration. So what you're going to write in this is that what happens down the group is that ionic radius increases. So ionic radius increase, and because of that, both lattice energy and enthalpy change of hydration, they decrease. So both your LE and hydration, they decrease. So both of them are decreasing. But since it's becoming more soluble down the group, that means the lattice energy decreases. It becomes easier to break the lattice. The lattice energy is decreasing more compared to enthalpy change of hydration. and overall your enthalpy solution is becoming less endothermic. ठीक है, ये typical question है which is going to come very frequently. What would happen if drops of NaOH are added to BaCl2? Nothing should happen. Because there's no ionic precipitation that's going on. A few drops of NaOH are added to BaCl2. Barium and OH ions, that's also soluble. NaNCl is also soluble. So I guess there's nothing going to happen. Sulfuric acid or BaCl2, something will happen. A BaSO4 solid precipitate would be formed. White precipitate. So insoluble barium sulfate is going to get formed. ठीक है, liquid gas वो कर लेते हैं. Thermal stability of group 2 nitrates varies down the group, so they become more stable. So they become more stable down the group. Why do they become more stable down the group? क्योंकि वो उसका वैसे बता देते हैं कि its ionic radius increases, its charge density decreases, less polarizing power. So the carbonate or nitrate ion becomes more stable. अच्छा, उसका देख लेते हैं कि उसको किस तरह ढूंढे कि gas liquid chromatography. 1 second. Not likely to ask about Boltzmann distribution. That would probably not happen. अच्छा, chromatography, एक second. हाँ, उसके 2-3 questions ही वो पूछते हैं. That's typical questions. Hold on a second. Questions निकालो उसके. अच्छा, ये question, I think this is 14. That's an old one. Gas liquid chromatography suggests what type of liquid is used. A non-polar liquid is used in a gas liquid chromatography. State what you would measure in order to distinguish between components in the mixture. The gas liquid chromatography, what you measure is always retention time. Okay, that is what is measured. Gas liquid chromatography hoti kya कि it's a tube, it's a long cylindrical pipe, and it's got a stationary phase in it, a liquid which is non-polar, और उसके अंदर ना एक mobile phase आप move करते हो, which is non-volatile gas. तो आपका जो column होती है, ठीक है, the pipe is referred to as a column. So it's got this stationary phase which is a liquid. Normally it's a non-polar liquid. Hexane is one example of a non-polar liquid. और उसके अंदर you pass it through a mobile phase which is argon or neon, an inert gas. और उसके अंदर there is mixture of dyes, vaporized dyes. ठीक है, so if a dye is dissolving in the non-polar liquid, it will slow down. It's going to take a longer time, stationary phase. And if the dye over here, vaporized substance, is not soluble in the non-polar liquid, it will continue to move. It will quickly come out of the other side. तो उसका जो retention time होगा वो paper chromatography RF values measure करते हैं ना. ये retention time measure करता है वो RF value. Distance traveled by the dye divided by distance traveled by the solvent. अच्छा फिर ये और कौन सा क्वेश्चन है? अच्छा, here's a gas liquid chromatography question. So the time is given over here, attention time. So वो column में से ना J came out quickly, K took a longer time, L took a much longer time. So say complete the table to suggest which compound in the mixture is responsible for each of the peaks J, K and L. तो mixture ये था कि in the mixture you had अच्छा तो आपके पास just a second. अच्छा ये you got an alkene, a carboxylic acid, and a ketone. So you've got an alkene, which is what? Non-polar. तो आपका जो column के अंदर ना the liquid that you had was non-polar. So the alkene is going to take a much longer time, simply because it's non-polar. So it's going to stay in the column for a very, very long time. Carboxylic acid is the one that's the most polar because it can form hydrogen bonds. So carboxylic acid would not dissolve in the liquid in the column, so it will quickly move out. It's going to take the least. Or ये beach वाला जो ना, that's a ketone. वो ketone है because that's not too polar because it's not forming hydrogen bonds, but it's still polar. तो ये भी उसके अंदर इतना dissolve नहीं करेगी. It will quickly come out, but it's going to take a longer time compared to carboxylic acid. ये clear है? ये चीज.
What do these peaks show?
वो column में से ये mixtures आ रहे हैं ना बाहर. So the peaks show कि भाई J, he got J first, then K first, then L at the end.
No,
बात
the
clear है?
heights of the peaks.
वो उसकी substance की quantity show करता है.
Okay.
कि अगर J ज्यादा डाला हुआ था ना इस mixture में, ठीक है, so there's more J, and they're going to ask you questions about हाँ ये उसने peak दिया हुआ है ना, तो they represent कि भाई which substance is present in what amount. So here, for example, they're asking for the percentage mixture responsible for K. So K कितना percent है? That's 18 divided by the total, which is 46 plus 18 plus 28 times 100. ये total था, उसके अंदर 18 is K. So you'll be able to figure out the percentage. निश्वा कार्बोक्सिलिक एसिड इसलिए first था कि आपका जो column के अंदर ना the stationary phase, the liquid that you have, that's your stationary phase. वो क्या है? Non-polar है ना? Non-polar किसको dissolve करता है? Non-polar dissolves non-polar. तो अब imagine करो कि भाई ये alkene जो है ना वो travel कर रहा है. तो alkene क्या होगा? Alkene will dissolve in the non-polar liquid. तो अगर यहाँ पे कोई बंदा बैठा है ना जो उसको wait कर रहा है, so it's going to take a much longer time because it's going to get mixed up with the stationary phase. तो alkene को बहुत ज्यादा देर लगेगी, ठीक है? It's going to slow down. वो इधर gas के साथ ना, it's not going to come out. ठीक है? The gas is flowing, inert gas. So the alkene would move into the stationary phase from the mobile phase. On the other hand, if you have a carboxylic acid, so let's say you've got another mixture that's, so let's say you've got carboxylic acid, okay? Carboxylic acid is one of the most polar substances. It's very polar. So carboxylic acid has nothing, it's not going to get attracted to the non-polar layer, which is why the carboxylic acid will just continue to move very quickly. So it's going to come out of the container, out of the column right at the beginning, okay? Hexane बस याद रख लो, stationary phase. वैसे अभी तक market scheme में they haven't anywhere they've written a name. They just say it's non-polar liquid. But hexane is used. तो इस पे इसी तरह के क्वेश्चन होंगे, कोई ज्यादा ये मुश्किल था बल्कि. They might ask you to figure out the composition of the mixture. So ये याद रख लेना, ठीक है? So nothing too complicated, ठीक है? Is this clear? अच्छा, ये और कोई चीज है? Thin layer की भी chromatography की question. Thin layer is more like paper chromatography.
केपीसी का एक क्वेश्चन करवा देंगे
किसका?
पार्टीशन कोएफिशिएंट का।
ठीक है, वो तो इस पेपर में देख सकते हैं कि केपीसी just 1 second. अच्छा, मिल गया, एक सेकंड. Thin layer chromatography, not necessarily. वो डिटेल याद रखने की जरूरत नहीं है. It's for thin layer chromatography is for separating any mixture, ठीक है? So if it binds with the stationary phase, which is a gel, a silica gel or Al2O3 gel, तो वो रुक जाता है, अगर वरना वो मूव करता रहता है सॉल्वेंट के साथ, ठीक है? अच्छा, खैर, इसके क्वेश्चंस. अच्छा, आगे केपीसी का क्वेश्चन. Question is, okay, there's 15 cm³ of hexane shaken with the iodine until no further change is seen. So, कितना 20 cm³ of aqueous solution, right? So 20 cm³ of an aqueous solution containing iodine. So you water it, and there's some hexane, which is 15 cm³ of hexane. So how much it is found that 0.390 grams of iodine is extracted. So यहाँ पे ना 0.390 grams I2 चला जाता है, ठीक है? So there was iodine in water, but now it's gone in hexane. So he's saying calculate the mass of I2 that remains in the aqueous layer. पीछे कितनी रहेगी? I don't know how much is left behind. He said that whatever amount of iodine you had over here, 0.390 grams got extracted into the hexane layer. So what is the amount that's left? We don't know. That's X. The KPC value is already given. The KPC, how do you calculate KPC? It's gram per cm³ in the hexane layer, which is 0.390 grams divided by 15. और नीचे क्या होगा? It's going to be water layer, that's X grams divided by 20. The value you already know, that's 93.8. इसको solve करो, you'll find the value of X. ठीक है? So that's KPC. और फिर इस पे भी वही intermolecular forces, they're going to link it up with intermolecular forces. So what happens in intermolecular forces is that वो कह रहे कि अगर hexane की जगह ना you had water, नहीं, so you still have water. Hexane की जगह ना you had a ketone. Ketone ही है, हाँ. What if you had a ketone? So what would be the value of KPC? Do you guys suggest how the value of KPC would change if you have a ketone hex, जो भी है hexanone, right? इधर hexane था. Hexane was non-polar.
KPC will be less.
ठीक है. Non-polar चीजें non-polar में ज़्यादा mix होती हैं. So in this case, there would have been more iodine traveling into the hexane layer because iodine is non-polar. तो iodine ज़्यादा होता है आपके पास hexane में. Now ketone is polar, so iodine will not इतना ज़्यादा move ना करता, ठीक है. So when you took the ratio of the solubility in the two layers, gram per cm cube, it's going to come out to be less. तो यहाँ पे अगर 0.390 grams है तो यहाँ पे कम होती वैल्यू, ठीक है, approximately let's say 0.20 grams होती, ठीक है. So that means less iodine in the upper layer, numerator would have been smaller and your denominator would have been bigger in size, ठीक है. So and the simple reason is non-polar iodine mixes well in non-polar hexane, but non-polar iodine is not going to mix in ketone, which is polar. तो इसलिए water से ना इतना ज़्यादा iodine would not travel into the ketone layer. ठीक है, ये clear है? अच्छा, then अच्छा, इन्हीं papers में से let's do some mass spectroscopy questions in वाले, ठीक है. So we've got ठीक है, let's do a couple of mass spectroscopy questions. Okay, let's do the last question, the whole of it. So we've got now we've got the first reaction, reaction 1, reaction 2. Write an equation for this reaction. So this is a carboxylic acid and an alcohol reacting with what? With SOCl2. So I think that's the so both OH groups are going to get substituted. So you're going to have CH2 with the Cl on this side, and the carboxylic acid Cl would also, the OH would get substituted. SOCl2 does that. Then you have W and X react together in excess of this is added to the reaction mixture, suggests Y. So W and X react together, right? So W and X are reacting, and he's suggesting that in excess of this is added to the reaction mixture, suggests Y. So salt add karen, CH3COO -1. So what could be the reason for adding the salt? So one of the reasons for that is, क्या reason हो सकती है वैसे? Why are you adding a salt? And what is the reaction that's going to happen? What is going to happen is that the acyl chloride will react with the amine. So the reaction that's taking place is that the acyl group, R-acetyl bond OCl, will react with the amine part from the other molecule, and they're going to form HCl. Okay, so they would end up forming HCl, and that's what's going to happen. So the acid being added over here would probably accept the H+ ions, the salt of the acid. So probably to get rid of the H+ ions that are going to be produced. So the amide link over here, this one, they've shown this. So the amide link that got produced over here, it was also producing an HCl molecule. So that is probably where it got used up. लेकिन इसका check कर लेते हैं कि why did they add a salt over here? One second. That's a 6. Hunting, that's it. To remove or neutralize the H+1 or the acid produced. Okay, that's why. So then you have the next one, which is W and X have reacted together, is added. We did that part. Uske baad wo keh rahe ki, draw the mechanism. Remember, electrophilic, this is addition, elimination of acyl chlorides. What happens is that this carbon over here is slightly positive. The N has a lone pair. What happens is that the N lone pair is going to get attracted to the carbon that's positive. And the electrons in the double bond, pi bond, are going to be repelled. The oxygen at the top would be slight negative. The Cl will be slight negative as well. The next part that happens is that the carbon over here, agar main isko pura hi draw kar lun, theek hai, you got a Cl. You've got an oxygen with lone pairs, -1 at the top. You've got a CH2 and you've got a Cl. And this N over here has joined from the bottom. And that's your aromatic ring. This N is positively charged. Why? Because it lost its lone pairs. It lost its lone pairs to carbon, which is positive. What is the next step? The next step is the electrons would reform the double bond, and the Cl electrons are going to repel. And that would produce this thing. It will produce the double bond O gets reformed. The Cl -1 is going to break off. The N has now officially joined.
Sir, the Cl is not going to have the partial negative charge in the very first step, right?
Yes. Partial negative है तो सही वैसे, पर देख लेते हैं. The first step है.
Yes.
हाँ, उसमें से उन्होंने हटाया हुआ है, ठीक है. So, but it is, I mean, even if you write it, it's still going to be correct. जैसे यहाँ पे उन्होंने मिस किया, लेकिन it is partial negative. I mean, this year. तो यहाँ पे उन्होंने सिर्फ वो लिखा हुआ है necessary कि what is the minimum required, right? Okay, obviously Cl is taking away electrons, so that is partial negative. I should explain why this acts as a nucleophile, because it's got a lone pair, which is going to be attracted to positive charge. अच्छा, फिर RF का question. Identify the substance used as mobile and stationary phase in thin layer chromatography. So mobile phase is a solvent. In this case, it's ethyl ethanoate. और उसके ऊपर top पे there's going to be a gel, a silica SiO2 Al2O3. That's your stationary phase. So as this solvent, this one over here, it travels. It's going to take whatever the mixture is. It's going to take that mixture. If the mixture bonds with SiO2 Al2O3, it's going to stop. If it doesn't, it's just going to keep on moving. I should describe how RF values can be calculated. It's the distance traveled by the dye divided by the distance that is traveled by the solvent. ये भी check कर लेते हैं, कुछ और तो नहीं लिख दिया उन्होंने. Distance traveled by substance or substance divided by distance traveled by solvent. ठीक है, same O-level stuff. Suggest why the RF values for X is less than that for lidocaine. That's so why is, we don't know what X is. Do we know what X is? I don't think we know. Achha, upar X. Achha, so why is this is X and this is this one? Now you can see that X is capable of forming hydrogen bonds, or it's more polar. Yeah, क्यों हो सकता है? One other reason could be that this one has more van der Waals forces. किसकी ज़्यादा पहले? Just 1 second. Who travels further? Lidocaine actually travels further. X travels lesser. So इसका मतलब है X is the one that actually stops on the gel. Lidocaine travels much further. So you can say that it's more polar. It can form strong hydrogen bonds. So it's more attracted to the gel. That's what you can write. So X is more attracted. Also, reason भी नहीं पूछी, just more attracted to the stationary phase, to the gel. ठीक है, ये clear है? thin layer chromatography wala.
Sir, the gel is polar.
Al2O3 SiO2, that's ionic, so it is polar.
Okay.
Al2O3 at least is polar. SiO2 is also polar actually. उसके जो ends होते हैं ना वो थोड़े से polar होते हैं.
Okay.
और इसमें हम remember this that this one is, I mean, you can't say it's completely polar, but it's slightly more polar compared to जो उसमें था gas liquid chromatography. से कोई और question नहीं है, कोई और चीज तो नहीं करनी.
No.
चल ठीक है, मुझे WhatsApp पे भेज देना, ठीक है, कोई questions वगैरह.
Sir, any general tips for the exam?
नहीं, मेन तो ये कि टाइम सेव टाइम, ठीक है. वो you see any difficult question by just, I mean, there's going to be at least one, or there's at least going to be 20 marks that are going to be difficult. So you see a difficult question, don't waste time initially on that, ठीक है. Just do the easy ones first, फिर उसके बाद end में ना try and do the difficult ones, ठीक है. जैसे अगर इस तरह का question है ना, for example, if you see a question similar to this, I'm pretty sure this is a very time wasting question. Whether it's difficult or not, it's probably going to waste a lot of time. So keep these questions or such questions at the bottom. I mean, this, for example, the NMR questions, leave it till the end. They require होते भी end पे हैं वैसे. But otherwise, try and do the straightforward questions. Try to just complete maximum paper first. उसके बाद फिर ना the difficult ones.
Okay.
चलें ठीक है. Okay then, take care.
Thank you, sir. Thank you.